Hi there. Hi there. This is the video for lesson 3.2, Maxima and Minima. This piggybacks off of our last lesson where we talked about increasing and decreasing interval. Now we're specifically going to identify maximums and minimums. Okay, now let's think about this logically. Using one of our tables before. Okay, so let's say I'm going to pick a random number, let's say 3. Okay, and I use the what we call the first derivative test. I don't think I used those exact terms last video, but finding the first derivative and testing it with the table, we can call that our first derivative test. Let's say 3 is one of our critical numbers. Okay, so now f prime at f prime of x, let's say, is less than 0. Okay, f prime of x here, let's say, is bigger than 0, which means this is decreasing, this is increasing, and this is all from last lesson. Okay, well, if we think about this logically, if this is decreasing, okay, and then this is increasing, right, then wouldn't it make sense that there is a minimum there? So that's what this graph kind of shows us. This, if I had, let's say, let's pretend that's 3. If this is decreasing and this is increasing, then we must have a minimum. The opposite is true. If this is increasing, this is decreasing, then we must have a max in between them. Okay. Now, a couple of definitions to go through. Local max, local min. That just means locally, or in a small section of the graph, there's a high point or a low point. Okay. Absolute max, absolute minimum would be in the entirety of the graph if there's a highest point and a lowest point. Okay, the analogy I like using in this for this in class is, let's say you are the best hockey player in your township. Okay, wherever you are, so you could be one of the local maximums, but you are not the absolute maximum because that honor belongs to Connor McDavid. So same kind of idea. Graphically, if I were to do something like this, okay, this point and this point, you can say, are both local maximums. Local, local, okay? However, this point is also a absolute maximum. It's the highest point in the graph. And then you could say this is a local minimum, okay? But there is, however, no absolute minimum, okay? Because it goes on forever. So it's just one local minimum. That is pretty much the gist of this lesson, okay? In these two scenarios, like for example for C, there's a local max, there's a local minimum, max and minimum, but there is no absolute max and there's no absolute minimum, okay? For any polynomial function fx, a point on the graph of the function where f prime 0 is called a critical point, okay? So negative 1, 4 is a critical point, okay? A critical number would be negative 1 as an example. So the x value in which the slope of the tangent is 0. Okay. So given a quick example, here's our given function, here's our interval. Okay. So now we're solving the coordinates of the endpoints. So negative 3, 6, 4, and 13 are the endpoints. And how did I get those? Just plug in negative 3 and 4 into our function. Okay. So graphically, negative 3, 4 is right there. Negative 3, 6. Yeah, negative 3, 6, sorry. And 4, 13 are right there. Okay? Now, we're going to find some critical numbers. How do we do that? Find the derivative, set it equal to 0, solve for x. And the two critical numbers we got are 2 and negative 2. Negative 2 and 2. Okay? How did I get these values? Again, sub into fx. Whatever our original question was, not f prime of x, sub into fx, okay? And then we did our test values to find that f negative 10 is decreasing, this is increasing, other way around, sorry. Sorry, my battery's about to die, so I'm trying to rush through this. Increasing, decreasing, increasing, which tells me that negative 2, so increasing, decreasing, which tells me this is a potential local or a max. And then for at this point it's decreasing then increasing, which makes this a minimum. So I'm going to plot those points, negative 2, 13 and 2, negative 19. So negative 2, 13, 2 and negative 19. Okay. Now looking at this graph and given the endpoints, okay, to identify local max and mins, so this is obviously a max. Okay, so negative 2 and 13 is what we call a local max, not an absolute, but a local. Okay, because this point right here, 4, 13, okay, actually I lied. This can also be an absolute max because the other point, the end point, 4 and 13, the end point is also a local max and an absolute max because they both have a y value of 13. Okay, now this endpoint here, negative 3, 6, this is a local minimum but not an absolute minimum because there is a point smaller. So this is a local min, also an absolute min. Okay, as always, any questions, please shoot on an email. Take care now.